Hello, and welcome to another episode of Crops TV Season 5. I'm Richard Roth, an assistant professor and extension nutrient management specialist in the Department of Agronomy at Iowa State University. And today I'm going to talk to you about identifying common nutrient deficiencies in the crops that we grow here in Iowa. So, as we move through today, we'll just do a quick review on the plant essential nutrients, and then we'll talk about identifying the deficiency symptoms of nitrogen, phosphorus, potassium, sulfur, and then a few of the micronutrients that we sometimes see deficiency symptoms of. So, plant essential nutrients, there's 16 of them. You can see them listed here on the screen. Carbon, oxygen, and hydrogen make up about 96% of all plant dry matter. We don't consider those when we're doing soil fertility programs because we get these from the air. But when we start to think about the nutrients that we do manage for, the first is the primary macronutrients. That's going to be your nitrogen, phosphorus, and potassium. These nutrients make up about 3.25% of plant dry matter. The next most common nutrients or highest amount of nutrients in the plant is going to be the secondary nutrients. That's calcium, magnesium, and sulfur. They're anywhere between a half to 1% of plant matter. And then making up less than 0.1% of plant matter combined is going to be the micronutrients. So these are chlorine, iron, zinc, manganese, boron, copper, and molybdenum. Now you'll notice here on the screen that I have 7 nutrients highlighted in red. That's nitrogen, phosphorus, potassium, sulfur, iron, zinc, and boron. And the reason that they're highlighted is because these are the nutrients that we typically see deficiency symptoms of here in Iowa and other surrounding states. The other nutrients that are not highlighted, we typically do not see deficiency symptoms for those. We also typically do not have, at least in Iowa, fertilizer guidelines for these different nutrients. Now, the other thing that we need to review about these nutrients is their mobility within the plant. And so mobility relates to whether the nutrient can move from one plant part to another within over time. And this is important because it helps us identify where we should look for deficiency symptoms to occur. So our mobile nutrients, such as nitrogen, phosphorus, and potassium, those are going to move from plant part to plant part. And so the deficiency symptoms for these nutrients are typically going to be observed in the older plant tissues first. So in corn, think the lower leaves, you'll see the deficiency symptoms first. Now on the immobile side, so your sulfur, iron, zinc, boron, these nutrients are immobile, meaning that they do not move from plant part to plant part. And so the deficiency symptoms of these nutrients are typically going to occur first in the younger plant tissues, so the newer leaves that are forming. Okay, so the first nutrient that we'll talk about is nitrogen. And so when we think about nitrogen deficiency symptoms, primarily in Iowa and surrounding states, we're really going to be concerned about corn. And so in corn, we have chlorosis. So that's going to be a yellowing of the leaf tissue. It's going to start at the tip of the lower leaves and it's going to progress inward along the midrib. So it's going to be your classic inverted V symptomology that we're used to with corn. We'll see a picture of it on the next slide. As I mentioned, you're going to look first on the lower leaves, but if it's a more severe deficiency, it will progress upwards over time. Now in soybeans, we don't typically think of nitrogen deficiency, but we can see it at times, specifically in areas where you may have standing water and things like that. It can be hard to discern what is a result of being in saturated soils versus having low nitrogen availability. But in the case that you would see it, typically it's going to show up as interveinal chlorosis. So that's going to be the yellowing between the veins and the leaves. And it's also going to result in stunted plants. And you'll notice later as we cover some of the other deficiencies that this is a relatively common symptomology And so it can be also confused with some of these other deficiencies that we'll talk about. But again, I think the key is to understand that mobility. So nitrogen is mobile. So this symptomology is going to show first on the lower leaves before it reaches the upper canopies. So here are some images of nitrogen deficiency in corn. You can see, as I talked about, that inverted V chlorosis there on the leaves. It's especially evident on the first and second pictures. You'll notice in the picture on the far right, you can see the deficiency symptoms have made their way up the plant. So even some of the higher leaves on the plant are starting to show that yellowing that we talked about. Now, here is an example of what nitrogen deficiency might look like in soybeans. Okay, so in the picture on the left, you can see the yellowing of the leaves towards the bottom of the plant. Again, that's the classic symptomology of nitrogen deficiency. But coupled with that, we can also have stunted root growth, so poor root growth, poor nodulation. You can see there in the picture on the right, in those plants that were lacking nitrogen, there's very little nodulation going on in those cases. Okay, so the second nutrient that we'll talk about today is going to be phosphorus. And so, phosphorus deficiency in corn typically appears visually as purple or dark green leaves. And then you may also have stunted growth in the plants, so shorter plants with fewer leaves. Again, phosphorus is a mobile nutrient, so we're typically going to be looking at the lower leaves, the older leaves on the plant. And this deficiency symptom tends to occur in areas with poor drainage or low fertility. So, if you have areas in your field that have low soil test P levels, those are areas where you may see this symptomology occur. You'll also see this more in cold and compacted soils as well. So, early planting, if we get a cold snap, you may see some purpling of the leaves that may or may not be a result of phosphorus deficiency. So, it's really important to, if you suspect phosphorus deficiency, maybe do some plant tissue sampling to confirm. In soybeans, it's not as common, but it can occur. And again, it's going to be dark green leaves with, a purple tinge to them, maybe some delayed maturity in terms of flowering and pod setting occurring later than you would typically think. And then also, again, you can have reduced root growth, which could, affect the growth of the plant in general as well. Because it's mobile, we're going to be looking at the lower trifoliates on these soybeans, especially as I mentioned in those low testing soils. And then finally, alfalfa, again, same, very similar story. It's going to be dark green leaves with a little bit of purpling. You can have some stunted growth, so shorter plants with fewer stems, along with reduced bud development, so fewer flowers, delayed maturity. And as mentioned with the previous two crops, you're going to be looking at the lower leaves, focus on the shoot tips, and this can also be seen in acidic soils as well. So here you can see a few examples of phosphorus deficiency in corn. You'll notice the purpling of the leaf edges and tips. This is the common symptomology that you see with corn. However, this can be confused with other symptoms that can occur in corn, especially if we have colder conditions early in the season. We can just have buildup of sugar in the leaves, which can lead to a purple coloration, which will dissipate over time. So, if you do suspect phosphorus deficiency, as I mentioned earlier, I think the key here would be to do some tissue sampling, also maybe pull some soil samples, determine if, in your soil samples, if you actually do have low P availability. With your tissue samples, you can determine if you have low P content in the actual tissues. And I think that can help you make a decision on whether it actually is phosphorus deficiency or if it's the buildup of those sugars due to that, cold conditions early in the year. Unfortunately, I don't have a picture of soybeans for us. As I mentioned, it's not common, and so there's not really much imagery out there for it. But here's an example of alfalfa. It's a little bit tough to see here, but you can notice that the trifolia on the left here is a little bit darker, maybe a purpley blue color relative to the leaf on the right. And so this is typically what you'll see in terms of alfalfa symptomology. It's that darkening of the leaves, You can also get some purplish blue type coloration to these leaves as well. So that's phosphorus. The next nutrient that we'll move into is going to be potassium. So potassium has yellowing and necrosis that's going to be related to the deficiency symptoms for it, kind of regardless of what crop we're looking at. When you think about corn, what we're going to end up with is that yellowing and necrosis starting at the leaf edges and working its way inwards towards the middle of the leaf. You can also have weakened stalks due to potassium deficiency, which can increase the risk of lodging. And so, when you're looking for potassium deficiency, it's going to be on those lower leaves again because potassium is mobile in the plant. And so, you may, if you have sandier areas in your field or areas of low organic matter, you may also try to look in those areas that you may see the symptomology occurring first in those areas. For soybeans, very similar story, yellowing and necrosis along the leaf edges. And with soybeans, you may also see reduced pod set. So that can be in the form of either fewer pods or smaller seeds. And again, we're looking at those lower trifoliates is where this symptomology is going to occur first. And then finally, with alfalfa, again, you're going to have that chlorosis or that yellowing along the edges that can lead to that necrosis, which is the cell death, right, turning brown. And you also may end up with weakened stems, so the plant may be more brittle. It can be prone to breaking, and all of this can lead to reduced forage yield because the plants may be stunted. You may also get poor regrowth after your initial cutting. So, as with the other plants, older leaves is where the symptomology is going to show first. A good time to maybe inspect alfalfa for some of these symptomologies, if you suspect it, would be during periods of rapid growth, or after heavy hay removal, right? And so, as that plant's trying to regrow, that's a good time to inspect and see if you can view any of this symptomology. Here are some good examples of what potassium deficiency looks like in corn. You can notice that yellowing that started on the edges. Actually, if you focus on the picture on the left, you can see that the edges have actually started to die. We call that necrosis. And you see that the yellowing of the leaves or the chlorosis that's happening is making its way in towards the midrib of the leaf. You can notice in the picture on the right, you can see the very lower leaves, the lowest leaves on the plants are exhibiting some symptomology, but in fact, the deficiency has started to work its way up the plant, a few leaves in this case as well. So next, we'll look at some examples of what potassium deficiency looks like in soybeans. So, you can notice in the picture on the left and on the right, you start with that yellowing around the leaf edges, just like with corn. And over time, that chlorosis, that yellowing, can actually turn into necrosis, so that cell death. And you can really see a good example of that right in the middle of the picture in the center of the page here. And you can also see that in the picture in the middle, this is an example where it was a pretty extreme deficiency and the chlorosis and necrosis actually worked its way up the plant. And so we're actually seeing that symptomology in the upper canopy of those soybeans. And finally, here's some examples of potassium deficiency in alfalfa. You can see that yellowing or that chlorosis starting to begin around the leaf edges. And then on the right, you can actually start to see a little bit of browning, which means that there's maybe some cell death starting to occur there as well. Okay, so next we'll talk about sulfur deficiency. So sulfur deficiency in most crops is going to appear as pale green to yellow leaves. You can get stunted plants in corn. It might result in striping. Unlike the other nutrients that we've talked about, sulfur is actually immobile in the plant. And so the deficiency symptoms of sulfur will actually appear on the newer leaves or the upper leaves first before you see anything lower in the plant. So, deficiency for sulfur is more common under cool, wet conditions, sandy soils, low organic matter content. Sometimes you'll see deficiency start to appear early in the season, and over time, it may resolve itself and you may no longer see the symptomology. So, I think in those cases, right, we need to use a few tools to indicate whether or not we actually are deficient in sulfur. So I think number one is just understanding the general characteristics of your field and your soil, right? If you have low organic matter in your field or if you have sandier soils, it's more likely that you have a true sulfur deficiency rather than one that may go away over time. Use your eyeballs. I think the biggest thing that you can do to identify sulfur deficiency is to identify the coloration and the symptomology on the actual plants themselves. And if it doesn't go away over time, then I think you may actually consider that you have a sulfur deficiency. And if you're really worried about it, a good tip might be, and really with any of the nutrients that we've talked about so far, might be to implement some replicated strip trials on your farm. Have strips with and without the given nutrient, do it for a couple years and see if there's a response to the addition of these different nutrients. And if it does happen, then that would indicate that you most likely are deficient in sulfur. And so you may want to add sulfur or whatever nutrient that you're testing for back in order to avoid these deficiency symptoms. So in corn, sulfur deficiency can actually be confused with a few different nutrient deficiencies, namely magnesium, manganese, and zinc. In Iowa and most of the surrounding states, I would say that, the two most likely is going to be sulfur or zinc. And there's a few key differences between the two that can help differentiate them. If you are worried about sulfur deficiency in corn, you're going to want to test it using tissue testing. So, soil testing is not going to give you any useful information in terms of sulfur. So, the only way to really diagnose sulfur deficiency is through tissue testing. Currently, the most recommended method for tissue testing for sulfur deficiency is going to be sampling ear leaves at silking. And so this can help indicate deficiency. You can see here on the screen the typical sufficiency levels that are associated with plant tissue S for corn. Same story for soybeans, right? We're going to want a tissue test. So the soil testing is not going to do any good for any crop, right? Soil tests for sulfur just are not reliable. So we'll focus on tissue testing. And for soybeans, that's going to be the uppermost full leaves, so fully expanded trifoliates prior to or at early flowering. And you can see the sufficiency levels listed on the screen. And then finally, alfalfa. If you're going to tissue test for sulfur, you're going to collect the top 6 inches of the plant at early bloom. So here's a few good examples of what sulfur deficiency can look like in corn. The striping on the leaves is pretty evident here. You can see that it's at the top of the plant. If you focus on the one on the right, you can kind of see that the very lower leaves there do not have the sulfur deficiency symptomology, but you can see it at the top, right? Again, it's because that sulfur is immobile, so the symptomology is going to occur at the top first. In soybeans, it's going to typically start out as in the picture on the left, where the plants are slightly lighter color green than if we were not deficient in sulfur. But over time, if we do have a severe deficiency, as you can see in the picture on the right, you can start to have some of those upper leaves start to die back. We can have some necrosis on those leaves as well. So, but the key is going to be that the symptomology is going to show first in the upper canopy, and then if it's severe, it'll move its way kind of down over time. And then finally, we have alfalfa. In the picture on the left, where the orange flag is actually alfalfa that is not deficient in sulfur. And then on the right hand side of the picture is where we do have that sulfur deficiency. The picture on the right is actually a zoomed out version of the photo on the left. So you can see that stripe of alfalfa in the middle that is suffering from that sulfur deficiency, the yellowing of the leaves, the stunted plants. You can really see that the plants here are much shorter than those where there was sufficient amounts of sulfur. Okay, so finally, we'll talk about some of the micronutrient deficiencies that you may see. These are the ones that are most common here in Iowa and some of the surrounding states. As I mentioned, beyond these, we typically don't see micronutrient deficiencies in any of these crops. And so, if you happen to be scouting your fields and you think, oh, this is maybe manganese deficiency or calcium deficiency, right? I would encourage you to maybe reconsider, do some plant tissue testing, check, because more likely than not, it's not going to be those other nutrients in terms of deficiency. There's probably some other cause going on. So for corn, the micronutrient that is most commonly deficient is going to be zinc. So zinc deficiency can lead to yellow to white bands between the veins on the leaves. It's an immobile nutrient, so it's going to show up on the new leaves first, so towards the top of the plant. You can also end up with broad white streaks near the base of the leaf. And you can also have shortened internodes, so the leaves may appear smaller and the plants may appear a little bit shorter. So, as I mentioned, you're going to look towards the top of the plant. It's likely going to rear its head earlier in the year, so in the 2 to 6 leaf stage. It's common in fields with high pH or sandy soils, also where you may have low organic matter. In soybeans, the micronutrient that we are most commonly worried about is iron. So you may have heard of this called iron deficiency chlorosis. It's because an iron deficiency is going to lead to yellowing of the leaves between the veins on the newer trifoliates, but the veins themselves are going to remain green. And we'll see a good example of this in just a minute. In a severe case, the leaves may turn white, the plants may die, and typically, this is not going to be across your entire field. This is going to be in patches in your field. So if you see patchy spots that in your soybean fields that are yellowing, especially if they are poorly drained, right? So standing water, or if they have high pH, you'll see these symptomology occur. So, this can also happen in compacted areas of the field, edges of the field, or areas maybe where you spread a high amount of lime or have a high calcium content in the soil. Then finally, in alfalfa, the micronutrient most commonly deficient is going to be boron. So with boron deficiency, you're going to have yellowing of the leaf tips on the younger leaves, maybe some red or purple discoloration on the older leaves. You'll have stunted growth, shortened internodes, and distorted leaves. Poor flowering, so reduced buds, reduced seed production. So to look at some examples of these deficiencies, we'll start with zinc deficiency in corn. So if you really focus on the picture on the left here first, you'll notice that you do see some of that striping on the leaves. You could see how you may confuse that for sulfur deficiency. I'll point out here on that, especially on that picture on the left, is I talked about you could get those broad whitish yellow streaks towards the base of the leaf. You can kind of see that starting to occur here in this picture, and so that's a good indicator that it may not be sulfur deficiency. On the right is an example of a less severe zinc deficiency, but you can see some of that white striping on the leaves starting to occur there on those upper leaves. In terms of iron deficiency in soybeans, as I mentioned, one of the key indicator here is going to be that yellowing of the plant tissue between the veins, but with the veins remaining green. You can see some pretty good examples of this here. But I also mentioned that it's going to be spotty in your field, right? You're going to be looking for these patches of stunted yellow plants. In that picture on the bottom right, you can really see a great example of this iron deficiency chlorosis showing up in a soybean field, and how it's patchy. It may follow water pathways through the field. It could also follow, if you have some calcareous soils in your field as well, it could follow that pattern as well. And finally, for the boron deficiency in the alfalfa, you can see that yellowing of the leaf tips, maybe some reddish coloration of the leaves a little bit lower down. This is a good example of it. This is less common, but if you have sandier soils, this can really rear its ugly head. So before we leave today, I want to share with you the ISU Extension Soil Fertility website. You can use the QR code on the screen. You can also type in the URL at the bottom, and you can find information on everything that I spoke on today here under the nutrient topics tab that you can see clicked and highlighted in the screenshot. And under there, you can go to the nutrient deficiencies section, and you can find good information on nutrient deficiencies. You can also, if you click on photo gallery, view some images of nutrient deficiencies as well. With that, I thank you for your time. You can visit my lab website for more information on soil fertility and nutrient management research as it comes about. And I'm happy to take questions from any and all of you at any time. Thank you.